Okay, sorry, I'm going to go back for a sec so that the video gets me going. Here's these. I will. Just relax. I'm just doing it for the video. Relax. Here's these answers. Here are these answers because I forgot to hit record. Now, there we go. John. Here's those 9. I assigned aces. If you recall, aces just means every other letter. Man, my life is a big difference when I drink coffee. I was very tired this morning and I feel a lot better now. Can you have a water? No. What? Never mind. They're talking to me. There's the bottom 3. Again, lowest terms. Is there anything anyone would like me to go over? Comments, questions, concerns? Going once, twice, thrice. Always have to do 3 times. Sold. Okay. Then the next page was, what is the difference between a 16-ounce brick and a carpenter? Did anyone get it? One weighs a pound and the other pounds away because he's a carpenter. He's a hammer. One weighs a pound, the other pounds away. It's funny. Okay. And then I wanted you guys to do this one. Why did the football coach send in a bunch of second string players? He wanted to tie the game. It's a pun on the word tie because tie also means to wrap something up with string. Yeah, but none of you were laughing. Haas and Joe. I'm a little hurt. Not really. I got enough confidence for you and me. Okay, so do more hysterical puns later. If you didn't do this last one, I think I told you it was optional. That's what it ends up looking like. It's this big mess of string. There it is. Okay, so that was a review of fractions. Now, we're going to look at comparing numbers just to make sure we're all on the same page here. So there's a bunch of little skills we're going to look at. Make sure we're all, doing okay with this stuff. So, comparing numbers. I want to compare some numbers. How do I do that? I want to order them least to greatest, and this first chunk is really easy. I think. Maybe it's not. Maybe I shouldn't say that. How do I order these numbers from least to greatest? Which number there is the least? I'm avoiding using a particular word. What's the least number there? It's not 8. It's also not 0. 8's not even on the list, guys. -8. There is a word I am avoiding using that sometimes people swap out with least. What word am I avoiding using, do you think, perhaps? Small or smallest. I am not using the word small or smallest. I hate that word in this context. Because -8 isn't small. It's actually compared to anything else here, it's the biggest number there, right? It's the biggest negative. And we talk about negatives being large, especially when we first teach negatives. Sometimes negatives get taught as debt. Is -8,000 a small debt? No, that's a pretty big debt. And so we're talking about, but is it, as far as having money, is -8,000, if you owe $8,000 to someone, that's the least amount of money you could have in this long string of things, right? So it depends how you were taught negatives, how you think about some of these things. I don't like that word smallest, but least I think it makes sense to talk about. Least implies to the farthest end of the number line to the left. Greatest being farthest to the right on the number line, because all math is done left to right. So -8 is going to be your least, followed by your -1s. I'm not going to put them on the number line properly yet. Followed by my 0, followed by my 2, and followed by 5. The reason I haven't put them on the number line yet is because I was a little picky when we reviewed number lines, about how I want you to do number lines. When you're putting things on number lines, I want you to make an effort to space them out reasonably. And so when we're spacing these things, they are going to be in this order, but I want to make sure we have them represented properly. If I'm putting negative 8 down there, how far over should I put my negative 1? Well, let's count it up. Sorry? Did you just say put it 5 over? Pretty far. Yeah, that's not a bad way to describe it. Well, how far is pretty far? Let's put it in here. When you're making a number line, don't forget, I want you guys to space them out reasonably, actually have them represent the values between these things. So that's negative 8, that's going to be negative 7, negative 6, negative 5, negative 4, negative 3, negative 2. There's my negative 1. And again, you don't have to get a ruler out to make sure these are all the same distance, but make an effort to ballpark the same distance. Then 0 is going to be the same distance to the right. We don't have a 1, but we've got a 2, 3, 4, 5. So do make an effort to space these things out properly. And it's not always going to be this scale. One of the things that we're going to do today is we're going to look at, well, obviously this is as easy as it gets, so we have an hour left. We have, water spritzer. We've got, to make it more interesting, right? And so we're going to start throwing fractions and decimals on these number lines. And so we're going to change what we're going up by. Each one of these went up by 1. It won't always do that. 1, 1. We won't always do that. So negative numbers are, I'll say lower, lesser, least. Pick a word that you want to fit in there. All of them sound awkward. But I don't want smaller. Negative numbers are lower, lesser, they're least. The farther you get away from 0, in other words, a larger, a bigger negative number, or the bigger the negative number. The lower, get rid of that smaller, the lower its value. I don't like that number small. Yeah, but I've thought about it since, and when I printed it out, I was like, yeah, this is okay. And then I was actually teaching it to the C block this morning. I'm reading, I'm like, no, I hate that. That's the worst. So I should have proofread it better, is what you're saying. Okay, so, bit of an aside. Let's talk about some decimal stuff, because decimals mess with people. When we're comparing sizes of decimal, I see a mistake that happens all the time here. It's related to this question. Which of those numbers is bigger? Hands up. Or it's just, take a guess. Hassan, which one's bigger? 6 cents. That's not even an option. 6 tenths. Oh, 6 tenths. Yeah. That's an option. I thought you said 6 cents. I heard money. Like, there's no 6 cents. That's 0.06. 6 tenths. Why is 6 bigger than 35? Yeah, this one's got 2 place values, so we better give this one a second place value too. If there's nothing written after the decimal place, what is it? It's a 0. So it really only makes sense to do the comparison if you have the same number of decimal places. You got to remember, this isn't 0.6. I mean, it is, but it's not just 0.6. This is 6 tenths, as Hassan said, but it's also 60 over 100, and this is 35 over 100. And so it's different enough. Make sure you add that extra 0 in there, and then it becomes a lot plainer to see. This number, 60, is bigger than 35, so 0.60 is going to be bigger than 0.35. The next thing I'm going to write down is a mistake related to this. Sometimes when I hear students count, and I've seen this mistake made in class, like a student made this mistake in front of me. And so don't say, I would never do this. Yeah, people do this. I see students count like this. So they're like, oh yeah, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, maybe you can see where I'm going, 0.7, 0.8, 0.9. What comes next? 1. 1 is what is supposed to come next. Anyone want to take a guess at the mistake I've seen? 0.10. This is the mistake I see all the time. And it all comes down to the language you use to count these things. And we talked about it before, and I was giving one of the very first lessons we did. Was we were looking at place value. We were talking about what these place values meant. These are tenths. So if I'm at 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10 is 1. This is not 10/10, this is 10 100ths. And so I just want to make that real clear as you're going through these, as we're comparing these values. The language you choose to use can have a positive or negative impact on how your understanding of the mathematics goes. Sometimes negatives can screw with us too. Here's some negatives. We've already kind of talked about it, so let's just crank it out. I don't want smaller. Get rid of that word smaller. When we think about it being lower, it almost is easy. It's trivial. It's not only is it easy, it's almost pointless. Which number is lower, -50 or -2? -50. When you think about it as debt, or when you think about it as temperature, -50 is lower than -2. You could still go outside in shorts and a t-shirt in -2. -50, you die in shorts and a t-shirt. Even then, it doesn't take long. -50 is really cold. -13 versus -14, which one's lower? -2 versus -1? -2 is lower. How about these? Fractions. We like fractions, right? 6/3 versus 4. Oh, some people are saying 4, some people are saying 6/3. Well, before we can even bother comparing them, we need to make sure that we have them looking similar. Let's reduce where we can. Can we reduce anything there? What is 6/3? Remember, fractions are just division. So 6/3 is just 2. So now the question has changed. This is 6 divided by 3 is 2. So the question is actually now, what's smaller, 2 or 4? 2 is smaller. So 6/3 is less than 4. How about the next one? 2 versus 6/4. Which one is smaller, 2 or 6/4? You're suggesting they're the same. It's a bold suggestion. Someone's saying 6/4. Who said 6/4? I heard a voice from the far side. It was a woman's voice, it sounded like. No, it's from way over there. From the far side of the class. Did nobody say anything from over there? Okay, someone other than Hassan Joe, because he'll teach the whole class if you let him. Samira, is that you? Yeah, I know, but this whole class could be a conversation between you and me, and I can't let that happen. Not because that's not good for you, but because it's not good for everybody else. What do we need to do to 6/4 to take a look at this? We could do long division. We could. Any other options? What kind of fraction is 6/4? It's improper. What can we do with improper things to get a better idea of what they look like? Make it mixed. So your options are this: mixed or long division. Long division would turn this into a decimal. But if we can see it with mixed, let's try it with mixed. 6/4. How many times is 4 going to 6? Once. With how much left over? 2 over 4. And 2 over 4 can be simplified to 1/2. So it's going to be 1 and 1/2. Oh, now we're comparing this. 2 and 1 1/2. That should be fairly straightforward. Which one's smaller or lower? 1 1/2 or 6/4. This whole column is the lower value, the least value. Does anyone want me to do the long division version of that question? Anyone want to see long division? That's okay, long division's coming in a little bit again. So here we go. How about this one? I had 2 sets of fractions. Was it you guys? Did I tell you guys about the whole A&W McDonald's battle that happened in the 90s? No. Wasn't you guys? Okay. So here's it is exactly this kind of question. So McDonald's second most famous burger, not the Big Mac, but the second most famous burger is arguably what burger? Who said it? I just heard it. The quarter pounder. Okay? The quarter pounder. So McDonald's throws down, they're like, yeah, we got the quarter pounder. A&W, true Canadian establishment, A&W comes out and says, we're going to make a burger. We're going to crank out the third pound burger, and we're going to charge you the same as the quarter pounder. How do you think A&W did? No, you'd be wrong. McDonald's, people were like, McDonald's is the better deal. Is that true? Why not? How do you compare fractions like these? What do we need to do? Long division is always on the table. But there's a better way. How do you compare fractions? It's the same thing you do when you add fractions. Because the only way to add fractions is if they are comparable. You need a common denominator. So again, two options, long division or find a common denominator. If I want to find a common denominator of two numbers, how do I do it? It doesn't have to be the smallest common denominator, it just has to be a common denominator. You can multiply the two denominators by each other, you bet. So if I'm going to take this one, 1/4 and 1/3, I'm going to multiply the top and bottom of this fraction by 3. I'm going to multiply the top and bottom of this fraction by 4. And what are we going to get? This one's going to become 3/12. This one's going to become 4/12. So which was the bigger burger? The third pound A&W burger. I mean, that's not accounting for taste. I will take a McDonald's hamburger or McDonald's cheeseburger over an A&W cheeseburger every time. My wife strongly disagrees. But I will take a McDonald's cheeseburger over it every time. But if all the burgers are equal, the quarter pounder is the smaller burger. It's ridiculous. Come on, Canada. Okay, so then same thing with this one. Common denominator of 3 and 7. What do I do with that? Multiply the top and bottom here by 7. Multiply the top and bottom here by 3. It might not be the lowest common denominator. It doesn't have to be the lowest common denominator. It just has to be a common denominator. Please stop bouncing the ball. Thank you. So 2/3 multiplied numerator and denominator by 7 is going to give us 14/21. And 4/7 is going to be 12/21. Surprisingly close. I would not necessarily have guessed that 2/3 and 4/7 were as close as they are. In which case, which one is lower? We still want the lower value. The 4/7 is lower because 12/21 is lower than 14/21. Nice. Flip the page. Let us do some review. When we're comparing numbers that are not just fractions, we're going to bring the decimals into this. We're going to bring a bunch of fractions with a bunch of different denominators into this. It's going to be great. A skill that is useful to have is being able to convert fractions into decimals. Long division is always an option. Is always an option. So is getting punched in the face, but sometimes I don't want to get punched in the face. Sometimes I would like an alternative that doesn't quite suck quite as much as long division can. Because I know that's how some of you feel about long division. If I walked up to you and said, I want you to do all these long division problems, or I can punch you in the face once, I know some of you would take the punch. Thank you, Justice. Okay? So there are other ways. It does require a little bit of memorization on your part, so let's take a look at it. There are easy techniques for memorizing some of these simple fractions. Let's go down here, and we're going to take a look at some fractions that it would be real useful for you to remember. I'll start by asking, are there any fraction to decimal conversions that you guys just know real easy off the top of your head? Austin, Joe, I know you want to say something. Yeah, you do. You got a fraction of decimal conversion in your head that's nice and easy? What's the first thing you thought of?
Long division.
Oh, you want a long divide? Yeah, man. That is the first one that block C gave me too. 1/2 is equal to 0.5. Absolutely. If you don't know that, now you do. I don't know how you avoided it this long, but there it is. Okay, the halves though, the halves give us access to what next nice little fraction group? What's a half of a half? Quarter. So if you got the halves, the quarters are easy. 1/4, 2/4, 3/4. Well, a half and 2/4 are the same because this thing reduces to that. So that's just 0.5. What's half of 0.5? Yeah, 0.25. Or the last time any one of you used one of these. I found this on the ground yesterday, by the way, so if you're missing a quarter, let me know. Sorry? It wasn't you, and I know you're lying because it was the other block. That was a trap, and you fell straight into it. I know it's not you because I know it's the other class. Okay, so if a quarter is a half of a half, well, that's going to be 0.25. To get 3/4, well, that's just 2/4 and 1/4 together. 3/4 is 0.75, or if you guys use change, 3/4 is 75 cents. Yes, I agree. What's next? What are some other easy fractions? You could take the quarters one step further. If you took the quarters one step further, you'd get... Oh, no, not up. More fractioning. What's half a quarter? An eighth. We could launch into eighths here. So I don't want to. That's too bad. Let's go. They're easy enough to calculate. So which ones line up here? 2/8 is the same as what other? It's the same as a quarter. So 2/8 is going to be the same here. The next one that's the same as 4/8. 4/8 is the same as a half. 6/8 is the same as 3/4. So now we just need to figure out the odd ones. 1, 3, 5, and 7/8. Well, 1/8 is just half of 2/8. So what's half of 25? What's half of 24? So what's half of 25? 12.5. So what's half of 0.25? Well, that's just going to be 0.125. See, all these things are related. All these math facts come together, make your life easier if you could remember them. So then 3/8 is just going to be 2/8 plus 1/8. What's 0.25 plus 0.125? Well, 0.1 plus 0.2 is 0.3. 2 and 5 is, and the 5 just comes hanging on for the ride, 0.375. To get 5/5, well, that's just this one plus this one. That's going to be 0.625. And 7/8, well, that's just this one plus this one, which is equal to 0.825. Again, I don't necessarily expect you to memorize these. The eighths, I mean. These ones you better. The eighths, not necessarily, but they're not hard to come up with. You have to ask yourself the right questions. There's 2 more groups of fractions that I will expect you to know. Where? I totally did. That should be a 7. Was that it? Okay, there's 2 more groups of fractions that I think it's entirely reasonable for me to ask you to know. The thirds. Let's throw them down. 1/3 and 2/3 because 3/3 is 1. What's a third? 0.3 repeating. 0.333333333, and I could be here forever, literally. 2/3 is 0.6 repeating. You can use the line notation or you can use the dot notation. They mean the same thing. The thirds are going to lead us into another one that's actually going to be really easy to memorize once you learn the rule for it. The thirds, and we're not going to jump to the 6th. We're going to jump to the next nice third. 7, no, never. Never, ever, ever, ever will I ask you to do anything with 7ths, because 7ths suck. You will long divide your way through 7ths before I ask you to memorize those because they're terrible. It's not 6. There's only 1 digit between 1 and 10 we haven't done yet. Well, that's related to 3. Sorry, we're going to do 5s and 10s in a second. Then. Thirds are related to 9ths. Let's crank them out. 1/9. Leave some space because there's a lot of 9s. There's 8 of them specifically. But they're easy. If you've never learnt them, that's fine. These are probably the easiest ones to memorize. Let's take a look at the 2 that are related to the thirds. The 2 that are related to the thirds are which ones? 3/9, because 3/9 is the same thing as 1/3. So 3/9 is going to be 0.3 repeating. And the other one that's related to the thirds is 6/9. 6/9 is related to 2/3 because 6/9, if you divide both of these by 3, that's going to give you 2/3. So 6/9 is 0.6 repeating. Oh, wait a second. That looks a little fishy, doesn't it? 3/9 and 6/9 are just the numerator repeating. Anyone want to take a guess at what the rest of them are going to look like? That's the pattern. Every single one of the 9ths is just the numerator repeated. 1/9 is 0.1 repeating. 2/9, 0.2 repeating. 4/9, 0.4 repeating. 5/9, 0.5 repeating. 7/9, 0.7 repeating. 8/9, 0.8 repeating. And 9/9 is 0.9 repeating, which is equal to 1, which is weird. 0.9 repeating is mathematically equal to 1. Should make you a little uncomfortable. But it does, and it's true. Okay. Someone said, well, what about the 5ths and the 10ths? Yeah, the 5ths and the 10ths are there too. Well, let's put them over here. Let's go back up to the top, because that's where I have space. I don't know where you have space. Fit in the 5ths. I'll go back to green. 1/5, 2/5, 3/5, and 4/5. What is special about the 5ths? Yeah, kind of. Yeah, you double them. So 1/5 is not 0.1, it's 0.2. 2/5 isn't 2, it's 0.4. 3/5 is then going to be, and 4/5 is going to be. And then the 10ths, do I have to write down the 10ths, or do we know our 10ths? I don't know if I have to write them down. 1/10 is 0.1. 2/10 is 3/10. It's just the whatever the numerator is, all on its own. And that covers like a ton of fractions. There's not much else I can give you unless I wanted to make you do long division, in which case I would give you things like sevenths. So like, let's just do one of those as an example here. I'm going to go top middle, and I'm going to change that question. Instead of 1/4, I'm going to have 1/7. And we're going to review what long division looks like with decimals or with numbers that are tiny. So remember, I put whatever I'm dividing inside, and I put whatever I'm dividing by outside. Does 7 go into 1? No, it doesn't. And there's no other digits. So we're going to add another digit. We're going to put a decimal point and a 0. When you put a decimal point in long division, directly above it, where your answer is going, you put another decimal point. That placeholder needs to be there. And now we go. Does 7 go into 10? Yeah, how many times? Once. 1 times 7 is 7. Subtract those two, and I'm going to get a 3. Add a 0, drop it down to 7, go into 30. I should say it this way. How many times does 7 go into 30? It is 28, but it doesn't go in 28 times. It goes in 4 times. Good. 4 times 7 is 28. Subtract it, gives me a 2. Add a 0, bring it down. How many times does 7 go into 20? Twice. 2 times 7 is 14. Subtract that, gets 6. Add a 0, bring it down. How many times does 7 go into 60? It is 8, because 7 times 8 is one of my least favorite multiplications. 7 times 8 is 56. Subtract that, that's 4. Add a 0, bring it down. When do we stop? I don't know. How many times does 7 go into 40? 5 times. 5 times 7 is 35. Subtract those, bring a 5. Add a 0, bring it down. We can see that this is going to go on for a while. I am not going to ask you to memorize your sevenths. Does it ever start repeating? I don't remember. Let's look it up. 1/7. Boom. Oh yeah, we need to go one more digit and then it's going to start repeating. Okay, let's go. How many times does 7 go into 50? Yeah, it's going to be 49, which means it's 7 times, because 7 times 7 is 49. 1, add a 0, and now we're back to the beginning. Does 7 go into 10? Yes, it does. It goes in once. So your sevenths are 0.142857, 142857, 142857. This set of 6 digits repeats itself. So no, I will never ask you to memorize your sevenths. The reason we want to be able to convert from fractions to decimals is because we want to be able to compare numbers that aren't necessarily cleanly aligned, I'll say. Before we do that, how do I go from mixed fractions to decimals? This one's easier. This one will be quicker than what we just did. Going from a mixed fraction to a decimal, there's 2 ways to do it. You can convert it to a mixed fraction in long divide. People on that far side of the class really seem excited about long division. Or the whole number can stay a fraction and become a decimal after the whole number. This is what I would recommend, guys, you get comfortable with. This is the method I want to see. If you want to do long division, fine. Do long division. If you wanted to do it, this first example would look like this. To turn this number into an improper fraction, what do I have to do? This is what we reviewed yesterday.
Multiply the whole number with the denominator.
Yeah, so 9 times 1 is 9.
And then add the 1 to the numerator.
Plus 1 is. So this would give you 10 over 9, and then you'd actually go ahead and you long divide this thing. And you're going to get, well, 9 goes into 10 once, and there's a 9, and then there's a 1, and then a point, 0, add a decimal, and then you bring down the 0, and it's going to be a 1, and then 9, and then 1, and then add a 0, and then bring it down, and 0, and it's going to be a 1 again. And you can long divide your way through a problem like this. But if you can remember some simple fractions, your life will become so much easier. If I want 2 and 1/5, if I can leave the whole number as it is and just bring in my decimal for the fraction, that's going to be a whole lot easier. What is 1/5 as a decimal? Well, Hassan Jod said, well, if for the fifths, you just double the numerator. So what is a fifth as a decimal? 0.2. So 2 and 1/5 is going to be 2.2. You just add the whole number to the decimal that you're getting. Likewise, 3 and 1/9. Well, the 1/9, the ninths I gave you a trick for. It's just the numerator repeated. So this is going to be 0.1 repeating. So 3 and 1/9 is going to be 3.1 repeating. What if some sicko gives you this? What is that? What's wrong with that? Who does that? Me. What's wrong with this? There's an improper and mixed. This is awful. Okay, so let's deal with it. The first thing you need to deal with is make this improper fraction proper. What should 5/2 be written as? Yeah, 2 goes into 5 twice. That becomes the whole. And then 2 times 2 is 4. 5 minus 4 is 1 and a half. So that's that piece. All I now have to do with the 4 is just add it to this. Well, actually, we're still not done because we want to put this into a decimal. What is a half as a decimal? 0.5. So this thing's going to be 2.5. And now just add the 4 to it. So 4 and 5/2 is 6/2. Or sorry, 6 and a half. You've all got the techniques for this. You can all do this. So what I want you to do now is this. I want you to take those numbers there. There are 6 of them. And I would like you to order them from least to greatest. Don't put them on the number line yet because I want to be picky about how that happens. But I want you to try this. You have 3 options for this. One option will always be long divide. Or decimals. Decimals are always an option. Or if you've got a bunch of fractions, what can you do with fractions? We've done it once already today. Starts with a C. Common denominator. But when you have 1, 2, 3, 4 different fractions, ninths, fifths, seconds, and thirds, or halves and thirds, common denominator might not be your best way to do that. I don't care which technique you choose to use. If you want to long divide everything, go nuts. You want to common denominator everything, cool. But I would recommend that you pick whichever technique is going to give you the least amount of work. And for a question like this, converting everything to decimals is the way to go. So, do that. I want you to put those numbers in order, not on the number line, but right here. Convert them all, put them in order. Go. When that dog is done. Put those numbers in order. However, whatever technique you want to use. Common denominator, decimals, or long division. Whatever is going to be the least amount of work for you. Yeah. That's one of the ones that you need to remember. Did you put your ninths on here? What one would be? Ninths? 0.2 would be. 3 ninths is 0.3 repeating. It's whatever the numerator is. 4/9 is 0.4 repeating. It's a handy bulletin board, eh? I got two people out of class right now. One of them is back in well, house notes we go and sorry, what's that? Well, yeah, do that. Yeah. There's about this here, why? For what it is. Exactly. Make friends, learn things. Fully on board. Take a look. Write it up. Don't number line them yet. Just list them in order. I'm going to be picky about how the number line goes. Okay, so lots of you guys have done this already. Where'd I lose you? Oh, I think that's not a good place to pause. Hey, would you do a bunch of those? You're great. Okay, so 3/9 is 23 so convert that to a decimal form. So what is 4/9 as a decimal? Always the ninths or always the numerator repeating? Okay. How about -2/5? Hassan and Joe gave us a good way to do the fifths. For the fifths, you just double the numerator. So 2/5 is oh, it's 2 double. It's fine. So it's going to be 1. Keep going. And then you got your halves. You have your half right over there. So this is a half. You're going to leave the whole number as it is. What is that as a decimal? Okay. And now what's this as a decimal? Sorry? No, you don't have to do just one of these two. This is the last one. But 2/3 is one of those we get. 2/3 is 0.6 repeat. That's one of those ones that is useful to memorize. So 1 and 2/3 is going to be 1, yeah, 1.6 repeat. Good. Just do it right now. Okay, so now let's order these things. Do you want your phone? Okay, do I see it again? It's mine. Hey, I will police. I mean, if you want to police them quietly, don't call them out after I've called them out. Okay, so these things converted to decimals is I think the least amount of work to do here. 4/9 is 0.4 repeating. Your fifths is -0.4. 2 is just 2. A half is 0.5. -1's -1. And 1 and 2/3. 2/3 is 0.6 repeating. So this thing's going to be 1.6 repeating. And now we're just going to put those in order. What is the least value on that in that row? -1. Followed by -0.4. Followed by we don't have 0.4. You're close. You're so close. Yes, repeating. 0.4 repeating. Followed by 0.5. Followed by 1.6 repeating. And then the last one is 2. And so now I want to put these things on a number line. I have provided you with a number line. The number line is not labeled. I'm going to go ahead and put 0 right in the middle. Right there. I'm going to call that guy 0. And if you count, you'll notice there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on either side. Now, I don't need to call each of those 1 because that wouldn't make a lot of sense. That means all of these numbers would be crammed between -1 and 2. So what kind of scale could I give our number line to make it a little bit easier to use? Who has a thought about how we could go up our number line? Sorry? I heard something. Austin Joe, was that you again? No, it sounded like your voice. Carson, was it you? Did Carson have a suggestion?
He said make it go up by 0.5.
We'll make it go by 0.5. That's an option. We're heading the right direction. If that's 0.5, that's going to be, if -0.5, that's -1. 0.51, 1.52. We could do that. It wouldn't use a lot of our number line, but it's better than what we've got. Does anyone have any other suggestions? Or are we going with Carson's suggestion? We could spread it out more. Justice, is that a hand? If we went up by 0.2, that's going to be -0.2, -0.4, -0.6, -0.8, -1, and 0.2, 0.4, 0.6, 0.81, 1.2, 1.4, 1.6, 1.82. That looks pretty good. If on a test or a quiz you threw down a number line and you said, oh yeah, I'm going to go up by 0.5, and Justice says, I'm going to go up by 0.2, both of them are totally acceptable. For the sake of this one and to spread it out, I'm going to go with Justice's suggestion, and I'm going to label these all going up by 0.2. Just to give us some space to put all these numbers down. 1.4, 1.6, 1.8, 2, and then this way it's going to be -0.2, -0.4, -0.6, -0.8, -1. So there we go. They have been so numbered. That was really the one thing I wanted to make sure that we had discussed before we just launched into you guys putting them on the number line yourself, the discussion about scale. So now let's toss these things on there. -1 is right here. -0.4 is nicely labeled for us too. It's right there. Where is 0.4 repeating? Where am I going to put that on the number line? Where's 0.4 repeating going to go? You were gone for a long time, man. Just to and from the bathroom? You took a walk. You weren't feeling good. Next time, let me know before you do that. Where am I putting 0.4 repeating? What's it going to go between on the number line on the positive side? Come on, guys. Is it bigger than 0.4? Is it bigger than 0.6? Okay, so where is it going to go? Is it exactly in the middle between 0.4 and 0.6? What is exactly in the middle between 0.4 and 0.6? Yeah, that's where the 0.5 is going to go. So 0.4 repeating is going to go just beside that. Because 0.4 repeating is 0.44444444. So that's almost 0.5, but not quite. 1.6 is, well, 1.6 repeating is going to go where? Sorry? Say it louder. Be brave, man. I'm pretty sure I thought I heard you say the correct thing.
Just behind the middle.
The middle of what? Between where and where? you may. If it was 0.6 repeating, absolutely, but it's 1.6 repeating. So the only thing that's going to change is what? Instead of being here, it's going to be here. Yeah. So right there, just below half, is going to be our 1.6 repeating. And then the last one is already labeled for us. It's 2. Coming up with a scale that works for your number line is going to be important for you to be able to do. Okay, one more thing and then we're done. Converting decimals to fractions is going to be useful as well. Sometimes we want to put things into fractions. How do we do it? Well, here's the, sorry, I need this. Here is a relatively simple technique for doing so. We looked at this already. Each one of these decimal places represents another tenth, right? So I got the tenths, the hundredths, the thousands, the 10,000ths. These are tenths. These are hundredths. This is the thousandths. These are the 10,000ths. And so each one of these, if all I had was this, you could write it as that value over the place that it's in. So 2, as Austin Joe said earlier, would just be 2/10. But if I had 0.23, that would be 23 100ths. 234 would be 0.234 would be 234 thousandths. So this thing's going to be 2,345 10,000ths. And we can put that over as a fraction. So here's how I've written it out. We want to find the decimal place of the last number that is not a 0. Whatever that thousandth, 10,000th, whatever the is, that's going to be your denominator. We want to write all the numbers after the decimal point as the numerator, and the whole number is going to be the whole number of a mixed number. And then we simplify. So if I have 2.19, what position is the 9 in? It's in the hundredths. So this is going to become 19 over 100. It's in the hundredths, so that's your denominator. The numerator the decimal portion becomes the numerator, and that whole becomes the whole portion of a mixed fraction. Can I reduce 19 over 100? No, because 19 is prime, and it does not divide into 100. So that's it. That is converting decimal to fraction. How about this one? Let's do this guy. Let's go 0.2. What position is the 2 in? It's in the tenths. So this is going to be 2/10. Is that in lowest terms? No. What's the lowest terms of 2/10? 1/5. I can divide 2 and 10 by 2. Divide by 2, divide by 2. Going to get a 1/5. How about this guy? It's the same. I mean, I could go straight and say, oh, well, this is 200 over 1,000. But now as I start reducing this thing, I can divide them both by 100. Divide by 100, divide by 100. I would get 2 over 10, which we then divide again by 2 and get your fifths. How about 3.4? What will we do with that? Anybody? Yeah, okay. So it's going to be 3 and 4 over 10. And can I reduce that fraction? Yeah, I can. I can divide top and bottom by 2. So that's going to give me 3 and what? 2/5. This last one, second last one, 2.05. This decimal portion is going to be what fraction? It's going to be 5 over 100. And that whole is going to become the whole number on the mixed number. Can I reduce 5 100ths? Anything that ends, you nodded. Anything that ends in a 0 can be divisible by 5. And 5 can end divisible by 5. So this is going to become 2 and 1 over, what is 100 divided by 5? 20. You can use your multiplication table for that too if you need. And then the last one, 3.001. What is that as a fraction? That 1 is in what spot? It's in the thousandths spot. So that's going to be 1 over 1,000. And the 3 becomes the whole number. So that's 3 and 1 over 1,000, or 1/1000th. Okay. Let's get you playing with some of these things. You guys are going to have to, so there's 4 questions here. All of them are compare the following numbers and order them from least to greatest. The first thing you're going to need to do is convert all to the same form. And I don't care what that is. You can convert into decimals, you can convert into fractions, you can make them all have common denominators, convert them all to the same form, order them, and place them on the number line. That is what I'm going to task you with. You know what? Let's say do the first 2 for me. You have time to do these first 2. If you got comments, questions, concerns for me, let me know. Otherwise, that is your task for now on your Mark It Set Go.